Welcome back to Huawei Routing and Switching Elite Training. Today topic we are going to discuss on STP spanning tree protocol. Let's start our part 5.
Here we have a topology, on how the calculation of CIST and the MSTI. Alright, first we are going to look into the common spanning tree vector. Now assuming that in this region 1, switch 1 here I have a priority of 0, switch 7 I have a priority of 4096, and switch 4 I have a priority of 8192. So assuming that there's a priority on our switch. So when they run the STP calculation, S1 will become the root. Okay, and you can see that between region 1 and region 3, this is the link, and between region 1 and region 2, we have a link between 2 and 4, and between these two regions we have 6 and 8. Now if you look carefully here, the port on S3, we call it as a designated port. So just think of it like I have 3 switches connected. So if let's say this is the root, this is the secondary. Alright, so here I have a designated port. So here I have a designated port, and here we will call it as a root port. Here we have the root port. Now you can see that there is also another port called master port. Now the master port over here is because that this is the shortest path for me to go into the root. Okay, so here we have the root or the master port. And between 6 and 8, because the region number 3 have a better priority compared to region number 2, the port on S6 here is being blocked as an alternate. So as you can see that the selection of the root for the CST is no different if you look into just like 3 switches connect together. Now once you understand this, then it will be easier for you to follow, because once the selection of CST is being selected, the next is that they are going to look into the MSTI internal. After we look into the CST, if you still remember that CST is that this is the root for our common spanning tree. But S1 is also the root for our internal spanning tree. Just to recap, internal spanning tree is the MSTI instance 0, which means that any VLAN that is not mapped into any of the instance will automatically fall under IST or internal spanning tree. Now here we have the root for our CST, and this is also root for our IST. And since this is a root, this guy will become the designated port, and here we have the root port. Alright, so here will be the same. So the port on S3, here we have a designated port, and here we have the root port. So you can see that both sides will be the same. Now if let's say we focus on the region number 3, as you can see that the connection here is that this is the root, and since this is a root, here we have all the designated port, and this is the alternate port. Is because that they are going to calculate based on the root path cost. Okay, so again you can see that this will be the alternate port here. So now we have a topology on the IST. So basically IST is for those VLAN that is not being mapped into the instance. Now after we look into the calculation of the CST, then we look into the IST. Now we are going to look into the MST instance. Now let's look into the region 1 topology. So region 1, we have 3 switches are connected in a triangle format. And in region 1, we have our instance 0, instance 2, and instance 4 at what's stated over here. And we also have our VLAN mapping. Now because every switch have a VLAN 1, and VLAN 1 is not being mapped anywhere, so VLAN 1 belong to instance 0. And here we have instance 2 mapped to VLAN 2, and instance 4 mapped to VLAN 4 as what you can see from here. Now because on the region 1, switch 2 have a priority. In this case we have instance number 2, the priority here is 0, let's say, so it will automatically make this as a root for the instance 2. So since you have the instance 2 as a root, so this path will be in forwarding. So between these two, they are going to do election on which one will become the alternate port. So here, the connection between the switch 1 and switch 3, this port will be alternate. And if you can see that on the switch 3, which is here I have a root, but this is the root for the instance number 4. Okay, so now you can see that the link is on this side, whereas for the instance number 2, the link is on this side. So you can see that how we can do certain load balancing, and all the link are being used now. Now basically the concept for the region 2 and the region 3 will be the same. So first we want to make sure that the root are being segregated and it being located into different switches so that we can have different path. And by maximizing the utilization of a link, so we can actually achieve certain load balancing. So this is for the region 2 calculation. And here we have the region 3 calculation. Again, you can see that this is the root for instance 4 and this is the root for instance 2. Now if we are going to conclude the whole thing and we are going to combine all of them together, now you can see that we have 3 different type of calculation. If you still remember, first we are first we are going to look into CST. So this is the root for the CST. And then we are going to look into the IST which is the instance 0. So if we look into here, the blue color is a CST. So here we have the forwarding, but here we are not forwarding. So we don't have any loop here. So once we have the CST, next we have the IST. So IST is those stored on the instance 0. Again, you can see that that's on the red color. Okay, so this is my IST. All right. And once you have the IST is done, next we are going to look into the MSTI. So for the MSTI, we have the root. So you can see that this is the root for VLAN 2 and this is the root for VLAN 4, or in this case instance 4 and instance 2. You can see that it marked with the different color. So with this, you can have certain type of the link utilization are being balanced out. So it's not 100% load balancing, but at least that the link are not totally unutilized. So this is the best part about the MST, because if you are just purely using the STP, you will not able to maximize the utilization of the link. Now we are going to examine the interoperability between MSTP, multiple spanning tree, and the rapid spanning tree. If you still remember, MSTP basically run on RSTP. Now the only difference over here is that when they send the BPDU, inside the BPDU they have certain information that the RSTP do not have. So let's examine what BPDU is being sent from MST to the RSTP. Now first thing here is that when we examine the BPDU on MSTP, we have our CIST root. Okay, if you still remember, that's our common and internal spanning tree. Now we also have the external root path calls. Then we have our regional root ID, and we definitely have our port ID. Now when this information is being sent by the MSTP capable switch to a RSTP switch, what will happen here is that the interpretation will be when the RSTP receive this, the CIST root will become the root ID. The external root path calls will become simply root path calls. Then we have the regional root ID will be our bridge ID, and finally the port ID will become the port ID. So here we have achieved certain compatibility when MSTP sent to RSTP. Now it's true for the RSTP back into MSTP as well. So based on this assumption, you can see that the MSTP and the RSTP can work without much of a problem. So they are compatible. So we don't have to worry if, let's say, one of the switch is in RSTP and the other switch is in MSTP. As in earlier slide, MSTP basically is still using the RSTP proposal and agreement. Okay, so the ordinary proposal agreement mechanism supported by MSTP is also implemented similar manner in RSTP. Just to recap, so if let's say I have a switch, we call it as upstream connect to a downstream. So here we are going to send a proposal. So here we have a designated port, and here we have the root port. Now when the upstream send the proposal to the downstream, assuming that you do have a non-H port, alright, so it will going to block this port temporarily. Okay, so the root port is specified and other non-H port will be blocked. Now the second agreement we're going to send, and this time the downstream is going to enter into the forwarding state. And once you go into the forwarding state, the downstream is going to send an agreement back into the upstream, and here the port will be in forwarding state. So we can see that the proposal agreement that on the MSTP is similar to what we have learned early on RSTP. Now let's look into the configuration. So first we are going to look into configuration of the STP. Then we are going to look into the second lab, which is configuring rapid spanning tree, and finally we are going to look into the MSTP. Right. Now on the first exercise that we are going to look into is a very simple exercise here. So we have 3 switches, okay, which is on company A. So what we need to do is to run STP, and by default the Huawei switch we have is MSTP. Then the second thing we have to do here is to ensure that S1 is always the root. So if you are going to make this as a root, then you can just configure as a root primary. Alright, and S3 is the alternate path. So S3, this part, we are going to make it as the alternate path. So which means that if let's say this is a root, we can do this as a secondary root. So if we have a root here, secondary root here, so basically the switch number 3 will become the alternate port here. So we are going to make this as a designated port, root port, designated port, root port. So we have a designated port and we have the alternate port over here. And finally we are going to change the port cost to 10. Okay, so we have to go to individual interface to change the port to 10. Alright, so let's start the lab now. Alright, so in my ENSP I have here switch 1, 2 and 3. Okay, so I already started. Let's go in. Now firstly we are going to change the mode into the STP. So when we do the display STP, as you can see that by default Huawei switch will change our mode default to MSTP. Okay, so STP mode STP. So this command STP mode STP will allow us to change the STP into STP. So I just do this in the other 2 switches. Okay, STP mode STP and STP mode STP. Alright, just to verify, display STP. Now you can see that we go back into the ordinary STP. Now next we are going to look into is that we are going to make the switch 1 as the primary. Alright, so that will be easy. So for us to do that, if I do a display STP brief, as you can see that I have a discarding port over here and the forwarding port over here. So it's the root and the alternate. So if I do a display STP, here you can see that my priority is 32768. That's the default, and this is my current MAC address. Now the root for our spanning tree is 299D. Okay, so now let's locate on who is 299D. So if I do in switch 2 display STP, alright, so 6394, and here 2993, which is switch 3. So if we do a display STP brief, you notice that this is a designated. So switch 3 currently is the root, but the question specified that switch 1 need to be root. So what we can do here is we are going to use a command called STP root. As you can see here, we have the primary and the secondary. So I'm going to do a primary, okay, and I'm going to make switch 2 as a secondary because I need this to be an alternate port. Alright, as you can see that switch 3 is still in designated port, so I need to change the switch 2 STP root to secondary. Alright, so I don't have to do anything on switch 3, and switch 3 automatically here will become alternate. So let's have a look here. So we do a display STP brief. Now you have it, so you can see that this is alternate port. Now since switch 1 is the root, then both the port will become a designated. So if we do a display STP brief, alright, there you go. Alright, and the switch 2, the Ethernet 001 will become the root, and Ethernet 003 will become a designated. So if we can just go in to verify. Okay, let me do a brief. There you have it. So we have the root for 001 and 003 we have the designated. Okay, so we meet the requirement. And lastly, the requirement by the question is that on all the port the cost need to be a cost of 10. Now if we do a display STP, okay, so that is on the switch number 1, you can see that the root path cost here is the 0, alright, because yourself is a root. If I go to the switch number 2, display STP, as you can see that the cost here is 200,000. So the the path for me to go into the root is 20,000. Sorry, 200,000. So we are going to configure that on all the port. Alright, the cost need to be 10. So let's just go into port number 1, and for you to configure the cost, just do a STP cost. Alright, STP cost. I go to number 2, STP cost. So we are going to do this on all the interfaces as what the question required. Alright, and the final one, switch number 3, interface number 2, STP cost is 10. Interface number 3, STP cost is also 10. Right, so if let's say we are going to do a display STP, now you can see that the path, the root path cost is 10. Okay, so that is all on the configuration on the first exercise. Now here we are going to look into the exercise on the RSTP, Rapid Spanning Tree Protocol. So again, we have a topology of company A, and we need to do the following. We need to run the RSTP, so our STP mode now will be RSTP. Okay, so we are going to do it on all the 3 switches. Whereas for the switch 4, we are going to do STP. Alright, so we learned that earlier on, should be no problem. And ensure that RSTP run on the 004 after the S4 is removed. So we don't have to worry anything here because RSTP and STP are backward compatible. So if let's say switch 3 and switch 4, when you connect them together and switch 3 detected that there's STP, it will downgrade from RSTP to become STP. And once the STP has been removed, okay, so RSTP will be reverted back. Now next we have to configure S1 as a root, so that should be easy, which is the STP root primary. Okay, and S3 will become the secondary, so STP root secondary. Okay, and set the port cost on the entire network as 10, so all of these will be 10. So we have to go to individual interface and we are going to set the cost as 10. Now next we are going to look into switch 3. Alright, 007. As you can see that switch 3 of 007 is connecting to a host. So we are going to configure as the H port. Alright, so inside the interface we are going to do a STP H port. Alright, and configure BPDO filter. So which means that if let's say we detected when you remove this PC, and you're going to replace with a switch. And when the switch start to send a BPDU, we are going to do a filter. So we are going to do a filter. All right, BPDU filter. Okay, and you should go into the arrow down when you receive a filter. So this is the command. And finally, we are going to configure root protection. Now the purpose of the root protection is because that this is the root as a primary, and this is the root for the secondary. On the port 004, assuming that if let's say switch 4 then make itself as a priority 0, there will be potential that the S4 become the root. And for you to prevent that, on the Ethernet 004, we are going to configure the root protection. Alright, so here I'm going to switch to the ENSP to show you how to do the configuration.
Thanks for watching. Please do not forget to subscribe to our channel.